Hello, everybody. In this video, we're going to be going through activity 238, which is going to be these head loss calculation practice problems. Pointing out some resources that we want to have up. Got the engineering formula sheet here. We're going to be referencing section 16, water supply. We got these three equations here that we're going to be using. Additionally, we're going to also be referencing section 18, Hazen-Williams constants, and then finally section 19, the equivalent length of generic fittings. Once again, be very, very careful. Do not use the screwed fittings unless specified. If it's not specified as being screwed fittings, you're going to be using flange fittings. Whenever it comes to the EOC, especially, make sure that you're using flange fittings, unless if for any reason they end up saying that it is a screwed fitting. All right. So those are going to be the formula sheet sections we're going to be using. And then also I've got the good old TI-84 calculator emulator up as well. So let's go ahead, let's get down to business. We want to make sure that we do a great job, as always, documenting our work, writing very clean, making sure we're unboxing our answers, and also writing out our units. So in question number 1 here, they tell us that we need to calculate out the head loss for a 8-inch diameter PVC pipe. And so that is giving us some information about C there, since it is PVC. I'm also noticing that it is a new PVC pipe. And so we're going to go ahead and scroll down here to a new PVC. So we got plastic PVC. It is giving us the designation of it being a new pipe. So that means our C value is going to be 140. Excuse me. Moving on. We've got the flow rate, which is Q. That is going to be equal to 108 gallons per minute there. And then they tell us that the length of this supply line is 4.5 miles. Now, keep in mind, I'm going to go ahead and write this out just from the get-go. We need to make sure that we convert this to feet here. And so we're going to end up multiplying it by 5,280 so that we can convert the miles to feet. And then additionally, we're going to also have an equivalent length here that we're going to need to calculate out. And so the length that we're actually going to plug into our Hazen-Williams formula is going to be this length plus our equivalent length due to those fittings. And so what they tell us, so we've got 2 gate valves, so I'm going to put 2 times. We'll put in that equivalent length there for 1 gate valve for an 8-inch diameter pipe. And then we've got 4 of the regular 90-degree elbows. And so we're going to plug that equivalent length in there too. All right, so let's go ahead. Let's pop back here. As mentioned, we have an 8-inch diameter pipe, so we're going to go down to flange fittings. And we're going to find the 8-inch diameter pipe. Now, let's see here. So these, we have 2 gate valves. So what I want to do is I want to look for gate valve. So gate valve, there we go, bingo. So we're going to go ahead and bring it down over here. 3.2 is what the equivalent length is for one of those, and so that's why we're multiplying that by 2, because we have 2 of them. The next thing that we've got are 4 regular 90-degree elbows, and so we're at 8-inch diameter. We got regular 90-degree elbows. It's going to be 12 feet for equivalent length for one. So we multiply that by 4 because we have 4 of those. So now we can end up performing the calculations for this. It's going to give us 6.4 plus 48. Then, just to play it safe, we can always use the calculator. So 6.4 plus 48, we end up with 54.4 feet. Now remember, I'm going to put this length with the total subscript on there, just like that. That's going to be equal to this length plus this length here. So let's go ahead. Let's find out how many feet we've got for our supply line length. So 4.5 times 5,280. We're going to have 23,760 feet there. Keep in mind that is a comma. So then now we can go ahead and add in that previous value of 54.4. And so now our total length is going to be that length plus the equivalent length, right? So it's going to be 23,814.4 feet. Okay, so that's our length that we want to use in our Hazen-Williams formula. And so now if we go back onto here, let's do a little check. Here's our Hazen-Williams formula, right? And so what we want to do is write this out up here. HF equals, and so now we can go 10.44. Ensure that we are using big parenthesis at the top of this, right? Times our length, which is going to be this value right here, times 23,814.4, times, then we've got next Q. So Q in this case is going to be 108. And then remember, that's going to be raised to the 1.85 power. We're going to put that big parenthesis there. We're going to do divided by. We're going to put a big parenthesis here too. C was 140. We're going to raise that to the power of 1.85. And then we're going to multiply that by the diameter, which is 8 inches. And we're going to raise that to 4.8655. And then we got a parenthesis at the end there. All right. So let's go ahead and let's perform this calculation now in the good old handy dandy TI-84. So we're going to put a parenthesis first, right? Then we're going to go 10.44 times 23814.4 times 108. Now we want to raise this 108 to the power of 1.85. And then afterwards, we're going to throw in that parenthesis. Okay, be very careful. Don't throw in the parenthesis before you put this exponent. If you do that, it's going to raise this entire part up to the power of 1.85. Now we're going to divide by. We're going to use a big parenthesis again on the bottom. We're going to go 140. We're going to raise that to the power of 1.85. Then we're going to press right on the keypad. Then we're going to multiply that by 8. And then we're going to raise that diameter to the power of 4.8655 there. I'm going to press right on the keypad again. Then we're going to go right here. Now I can go ahead and press enter. And so what we find out is our total head loss is going to be 621. And remember, this is feet of water. You can also put feet of H2O there. And so that is the head loss. All right. So they're asking, yep, what is the head loss? So what we're going to go ahead and do is we're going to type in 6.21. Now remember, we've emboxed our answer. We put the unit on the documentation. However, in that question, we're going to just put the numerical answer. All right. So let's go ahead. Let's move on to question number 2. So question number 2, we've got a diameter now. It is 10 inch diameter, and we're dealing with cast iron. Now, they do not make any designation that this is a new cast iron pipe. So because it's just cast iron, we're going to use that typical design value. So we can go right here. Cast iron's our first option. Typical design value is 100 there. So we're going to put C down equals 100. And then now, in terms of other important information we need to write down, Q in this case is equal to 3 gallons per minute. Wow. Hardly any flow rate. I'm surprised that there's even a flow rate for this. It's probably some issue that I need to end up fixing with this to make this a bit more realistic. But just keep in mind, guys, you might end up getting some different numbers. For all these, you're going to have different numbers. Every time you take this quiz, you're going to have different numbers. Although this is pretty small, we're still going to calculate it out. All right. If the pipe is 9 miles long, wow. So length equals 9 miles. Remember, we do need to multiply this by our conversion factor, 5,280 feet. That is in 1 mile. We multiply by this fraction, so the units of miles cancel. Then we'll be left with some value of feet. And then we have the following equivalent length calculation. So we've got 1 gate valve, and then we've got 3 regular 90-degree elbows. So this is for a 10-inch diameter pipe, 1 gate valve. So let's go ahead and let's do that. So 10-inch diameter. We've got 1 gate valve here. So that's 3.2 is the equivalent length for 1. And then we've got 3 of the 90-degree elbows. So that's going to be 14, right? And so that's for 10-inch diameter. Perfect. And so now we can go ahead and perform these calculations. We got 3.2 plus, that's going to be 42, right? Let's go ahead. Let's make sure that we do our calculations correct here. Don't want to be just crushing our mental math. Okay, perfect. 42. Yikes, made a mistake there. Let's put 10, 15, DR. Remember, anytime we make a mistake, initial and date. So that's going to be plus 42. And so now that needs to be 45.2 feet, right? And so we're going to add this equivalent length is what we just got there. We're going to add that equivalent length to whatever we end up getting this in terms of feet. So let's take 9 times 5,280 plus, and then if you go up on the keypad, you can select that 42. Oh, but then we got to add the 3.2 on there as well, because it wasn't just 42, right? It was 3.2 plus 42. So now we've got this length here. So I'm going to put down this length originally, which is just 9 times 5,280. That was 47520 feet. And then I'm going to put down here, so you guys can see this, L with a subscript total. Now, L total, we just calculated that out. That should be our 47,565.2 feet is our length. Okay, so that's going to be the L value we're going to use in our actual Hazen-Williams formula. And so right here, we've got HF equals, remember, we got to use the big parentheses, 10.44 times our total length, 47,565.2, multiplied by Q, which in this case is a very small 3 gallons per minute. We're going to raise that to the power of 1.85. We're going to put the parenthesis. We're going to divide that by, and then we're going to have a big parenthesis on the bottom again. Now, remember for this, if we go into here, if you need the refresher, C. So C is on the bottom here. C is 100 in this particular scenario, and that's raised to the power of 1.85. Then we're going to multiply that by our diameter, which is 10 in this case, raised to the power of 4.8655. We're going to close that big parenthesis, and so now we can go ahead and punch this into our good old TI-84 calculator. So we've got big parenthesis here. We got 10.44 times, and then we're going to put in the 47,565.2 times 3. We're going to raise that to the power of 1.85 here, right? And then we're going to put a big parenthesis again. We're going to divide this, and then we're going to put a big parenthesis on the bottom, 100. Then we're going to raise that to the power of 1.85. Now, guys, if you're wondering how I just did that without selecting this guy, if you press Shift and 6, it'll actually do that for you, where it'll raise it to the exponent. We're going to multiply this then by 10. I'm going to press Shift and 6 again so I can get to that exponent. And then I'm going to go 4.8655 here. Press the right arrow key to get out of that exponent. And then now we can go ahead and press Enter. And so because our gallons per minute, our flow rate, so small, we ended up getting a very minor head loss here. And so the head loss for this example here is 0.01. And I'm going to go ahead and go out to 0.3 because this does accept 5% error. So I'm going to go all the way out to 0.0103 just to make sure that we're good. And so that is the amount of head loss for this second problem here. All right. Third problem, I think you guys get the point by now. Wish you all luck, happy calculation, and are calculating, and hope this was helpful. If you guys got any questions, please feel free, drop them in the comments. I'll be happy to assist. See y'all later. Bye-bye.